I will just write down the telescopic setup for each one. First step is sigma r goes from 1 to n, 1 upon r into r plus 1. I think we have done this in class, which is equal to sigma r goes from 1 to n, 1 upon r minus 1 upon r plus 1. This is the telescopic setup. And therefore the answer is 1 upon 1 minus 1 upon n plus 1. Done
Yes, sir.
that fast. Second will be slightly different. R goes from 2 to n. 1 upon r minus 1 minus 1 upon r. I am just trying to keep it positive. And in general, if you keep it left hand side term, smaller term, and right hand side term, bigger term, then it is less confusing, because in the left hand side term, you should substitute the lower limit, and the right hand side term you are supposed to substitute upper limit. That is the answer. Then comes the third, sigma r goes from 1 to n. 1 upon r square plus 3r plus 2. So r plus 2, r plus 1 into r plus 2. That is most important. If you don't get the factorization of denominator, then it is going to be difficult to set up the telescopic sum. 1 to n, 1 upon r plus 1 minus 1 upon r plus 2. This is the setup. 2 minus 1. You have to cross check whether you are generating any constant or not. Here we are not. The smaller term is 1 by 2 and the higher term is 1 upon n plus. You can simplify and report the answer in some different form. Now fourth. Sigma r goes from 3 to n, 1 over, what are the factors of that now? R minus 1 into R plus minus 2. Again, one jump. Therefore, sigma R goes from 1 to n, 1 over R minus 1 minus 1 over R minus 2, 3 to n, 3. And that is why it starts from 3. If it starts from 1, then this becomes undefined. If it starts,
Sir, it should be 1 upon r minus 2 minus 1 upon r minus 1.
Yes, sir.
Yes, sir.
Yes, sir. Sir, r minus 2 will come first.
Sir, 1 upon r minus 2 first.
bigger, huh? Oh, okay. Otherwise, I have to take minus sign outside. Okay, so 1 upon r minus 3 minus, 2 minus 1 upon r minus 1. So minus 1 minus minus plus 2 makes it positive. I was explaining why this 3. It is actually the hint given to you that the denominators are going to be r minus 1 and r minus 2, because the sum becomes undefined if r starts from 1. Therefore, it starts from 3. So smaller term is 1 upon 1 and bigger term is 1 upon n minus 1. So that is the answer. Okay. Now fifth. This is the fifth term. Sigma r goes from 1 to n. 2r plus 1 upon r fourth plus 2r cube plus r square. Okay. So first thing that you must do is factorize the denominator. R goes from 1 to n. What are the factors of denominator?
R square and R plus 1 square.
R square and r
R square plus
1 square. Numerator is 2r plus. These are easy problems because whatever numerator is generated is given in the problem. So sigma r goes from 1 to n, 1 upon r square minus 1 upon r plus 1 square. If we set up like this, here you have to check, because while separating these two terms, you are not aware of this. But then when you cross multiply, because if the LCM is r square into r plus 1 bracket square, then you have to cross multiply and expand. So expansion r square plus 2r plus 1 minus r square, and therefore you end up getting 2r plus 1 in the numerator, which is already there. Therefore this is the telescope. So unless you check this, you cannot declare that my telescopic setup is done, and hence the answer in this case will be is equal to 1 upon 1 minus 1 upon n plus 1 bracket square. Okay, up to 5. Up to 5 we have done. Do you have anybody has got any difficulty, not understood? Okay, so up to 5, the principle of setting up the telescopic sum is exactly same, and all of them happen to be one jump telescopic sums. You cross check whether these two terms are separated by minus sign. Yes. Is the given sum and the sum after separating is same or not? You have to tally them. You may end up getting some numerator constant, some algebraic term in the numerator. Everything should be fine. You just cannot change the problem because you are getting telescopic setup. You cannot change the LHS given to you. It is fixed. So algebraically you have to cross check whether the telescopic setup is done or not. And first term is one jump. If you substitute r is equal to r plus 1 in the first term, you get the second term. That is very important statement. Now let us, the problem number 6 is also of the kind problem number 4. Factorization is r minus 1 bracket square into r square. So I am not solving that, it is exactly same. Let us look at 7th problem. 5r square plus 5r plus 1 upon r square plus 1. Sigma r goes from 1 to n. Now the difficulty level,
Sir, R square plus R.
r square plus r. So difficulty level in this problem is added little bit. Numerator is not as easy as earlier problems. It is little heavy. Heavy in the sense degree of denominator, which is 2 quadratic, and degree of numerator is also 2. So it is bhai hai, numerator or denominator. But then we would like to have long division done first. So instead of long division, we can always adjust the terms so that we save time. So sigma r goes from 1 to n. We adjust it like 5 into r square plus r plus 1. I mean this sum is inviting for this factorization. Okay, so first if you split them into parts, you get sigma r goes from 1 to n 5 plus sigma r goes from 1 to n 1 upon r square plus r. This is problem number 1, P1. And this is problem number minus 10. We have done it in our workshop. This is 5n. And this is 1 minus 1 over n plus 1. That is what is the answer for problem number 7. Problem number 8. So, what is the learning value here? Learning value is, I mean additional tip. If degree of numerator is greater than denominator, perform long division. Log नहीं, perform long. Log ला वेळ आहे तुमच्या. So, do you understand the long division that we have performed here? This is the long division. I mean factorized the denominator out and got cancelled. Therefore, you will end up only having 5 here. I hope you have understood this. Good. Now what should I do? I should keep this so that students can see it, and I should have my problems also. So I have a facility of copying them again. We are in electronic era. So maximum laziness, minimum hard work. That is the era which is going on. Okay. See, now you find yourself, we have to play with r plus root 3r into 2 plus root 3 plus 1. Okay, so we will play with this term first and go to telescopic setup next. So root 3, let us multiply 2 into r. That is the only thing that we can do, and then try to factorize or something. This is good. This is root 3 and this is root 3 plus 1. Okay, so if I add 1 to this, I get this. Similarly, so let us see 2r. This is 2r plus root 3r plus r plus 2 root 3. Is that right? No. R
Yes.
into 2, that is
Sir,
this.
अजून एक root 3.
अजून एक काहीतरी आहे ना?
Sir, 3R plus root.
प्लस 3 आणि रूट 3 येतील.
हा, थांबा. Correct. So we have 2 root 3 plus 3 plus root 3. Correct?
Yes, sir.
So we have 3 root 3 plus 3. We have 3r plus root 3r. Aha. Is that correct? So if I take 3 inside bracket, r plus
And one R.
huh?
And one R. Sir, 2R plus root 3 plus R.
Add केलं.
Okay.
काही नाही सर, तुम्ही ऍड केले.
Yes, sir.
बरोबर आहे ना?
Oh, sir.
बरोबर आहे.
हो सर.
Plus 3r
So we can take 3R common.
wait. Now, have you solved or no? Have you solved this problem? Then you tell me the answer. Otherwise, let me think. Because this problem, I remember, is created by me only in some previous exams. Maybe
Sorry, sir.
9 years before. I don't know. I don't remember. But the lecture notes, whichever I have sent you, that was the first version of our lecture notes, and those are the only telescopic sum problems for students. Okay, so it is r plus root 3 and r plus 1 plus root 3. Suppose eventually it is going to be something like this. Then is that r square missing there or something? Is there a correction or setup is not there? But this is not noticed by anybody. This sheet is being sent to almost all batches. Then this will go for r square. Okay, in this case it is 3r plus 3 root 3, and if we take 3 common, then it is 1, 3, then it is only root 3, so it is r upon root 3 plus 1. That is the factorization, which is r plus root 3 upon root 3. Okay, so it is going to take some time unless I declare that it is Not correct. Suppose I write R here, then is it doable? Yeah, I think this should be R. R in, yeah. My goodness, nobody has noticed this yet. This
Yes, sir.
otherwise this is impossible because you have to have R square in the denominator. Let me check. I have got another sheet. Yes. So I had sent you easy problem set only because only one lecture on telescopic was done. It is supposed to be easy problem set, and the problem 12 had a good. Now, if something like this happens, then respect about students in teacher's mind increases, because if it is a wrong problem, it is a wrong problem and not solved by anybody. Correct. Very good. Now, in 11th and 12th, after I teach students for 3 years or so, okay. Next problem is find sigma r goes from 3 to n 1 upon r square minus 4. Don't simplify the final answer, keep it as it is. Next, sigma r goes from 2 to n r upon this denominator plus sigma r goes from 2 to n 3 upon this denominator.
And can you switch off the spotlight?
And now Bhargavi is only visible. I am also even not visible because I have spotlighted, replaced a spotlight. Okay. So sigma r goes from 2 to n r plus 3 upon. Now can we factorize this denominator? Yes, I think r plus
Yeah, we can.
1.
R plus 1, R
R
minus
plus
1,
3
R
into
plus 3.
R square
R
minus 1.
plus 1, R minus 1, R plus 3.
R plus 3, R minus 1.
is equal to this. So now this
Also
Then
R
R
plus
plus
R
1.
plus 1 is
Sir,
also
even
there.
R
Right?
plus 1 is there in the denominator.
Sir, R plus 1.
yes, sir.
one more term, r plus 1.
Yes, sir.
So
Sir, R plus 1 into R minus 1. And
degree 3, yes, you are right. R plus 1, R minus 1 and R plus 3. Okay, so this is what is your denominator, and this gets cancelled. Further simplifies, and I think we have solved this problem. 1 upon r square minus 1. Sigma r goes from 3 to n. So it is P2, I think, na? Or something. P3. Is it P3? Let me check.
no, sir, it is P11.
The doubt.
P11.
Why can't we do R is equal to 1, because we will just get 0, nothing else will be affected.
In P11, it is r is equal to 1 or r is equal to 2?
So I don't know.
R is equal to 2.
Yes, sir, it is 2, but why can't we do R is equal to 1? Like,
Because if denominator is 0, then it will be 0.
Yes, sir.
Yes, sir, not
R
defined.
minus 1 will be 0. So it will be undefined.
Correct. Next problem. Okay, next problem is sigma goes from r is equal to 1 to n. 5r square plus 9r plus 3 upon r into r plus 1 upon 2r plus 1 upon 2r plus 3. Okay, when it is prove that type, that means you have been given RHS. That makes life very easy. If it is find, then it is extremely difficult. Okay, so let me explain it to you. Here anyway you have 1 upon 1 plus 1 upon, 1 upon 1 minus 1 upon n plus 1 plus 1 upon 6 minus 1 upon 4n plus 6. So when you put r is equal to 1, you get this term. When you put r is equal to n, you get this term. When you put r is equal to 1, you get this term. And when you put r is equal to n, you get this term. So for these two, it should have been 1 upon r. When I put r is equal to 1, I get this term. And 1 upon r plus 1. This is the guess for this answer. What is the guess for this answer? I mean, you can take out half common, makes it 1 upon 3 minus 1 upon 2 n plus, in place of n you put r, 2r plus 3. When you put r is equal to n, you get this term. When you put r is equal to 1,
2r plus 1 सर तिकडे खाली.
इथे काय पाहिजे?
2r plus
2r plus 1 ना सर. सर कारण की जर r equal to 1
okay. It should be 2r plus 1, and therefore if you put r is equal to 1, you get 3. Correct? So this is what your first step before your final answer. I mean, this is, sorry, 2r.
So it should be 2r
तर
plus
2r
3.
plus 3 आणि
2r
instead of
plus
1 by
3
3
and 2r plus 1.
2r plus
2r plus 1. I mean, these guys are sitting here now. So you have to use them. Those denominators are going to continue with denominators. So 2r plus 1 here.
yes sir, and 2r plus 3 there.
Is this correct now? I think so. Okay. In this, we have to put r is equal to r minus 1 to get this term. Okay. So if we simplify this to this LHS, then our job is over. This is 1 upon r into r plus 1 plus half times. What is this? 2r plus 3 minus 2r minus 1 upon 2r plus 1 into 2r plus 3, which is equal to which is equal to 1 upon r into r plus 1 plus 1/2 inside bracket 2 upon, so this 2 gets cancelled, 1 upon 2 plus 1 into 2r plus 3, which is equal to, you cross multiply, so you get 4r square plus 6r plus 2r plus 3 plus r square plus r. Is that right? Everything in the numerator divided by 4 brackets, which is equal to 5r square plus how many r's? 9r.
9r plus 3.
Plus 3. 1. Now, if this is available, this is the way to go. But if this is not available, then it is extremely difficult. And what you need to do is, you have to write 5r square, because
Sir, we have to write it as r square plus r plus 4r square plus 8r
Yes,
plus
sir. Yes, sir.
But how did you put 6 as 2r plus 1?
you have to write the numerator like this and
yes, sir.
deal with
And
it.
divide it into 2 parts.
Yes, sir.
Okay, is it clear? So now we have saved time, so you can try this.
So how did you put 6 as 2r plus 1?
You are asking here?
Yes sir, second.
Yeah, because I could find out this term 2r plus 3, and when r is put r is equal to n, we will get this term. And by the rule of telescopic setup, this term should be one less, one jump behind. So you put r is equal to r minus 1 here, 1 upon 2 r minus 1 plus 3, that is 2r plus 1. That is one way of looking at it. And second way of looking at it is these denominators will continue to be there, and it is there 2r plus 1. So it has to be present somewhere in the denominator after you split them. Then only they will appear in LCM.